From the Chilled Water Services team at OUC, the reliable one, welcome to OUCooling. This introductory video will briefly explain how OUC chilled water is delivered to your building in downtown Orlando and how your internal cooling system is controlled. We'll also provide useful information about how to improve its efficiency. OUC has 3 central chilled water plants in downtown Orlando that supply OUCooling customers. From these state-of-the-art facilities, we pump chilled water through underground pipes to buildings on our network. OUC provides a minimum of 1 pound per square inch of differential pressure, or 1 PSID, at the point of delivery, which for most customers is the first floor mechanical room where the chilled water lines enter your building. We'll talk more about the importance of differential pressure in our next video. From there, internal building pumps, operated and controlled by your energy management system, send chilled water to air handlers for common areas and larger tenants, or to fan coils used by smaller tenants and residential units. To capture the amount of energy used in your building, OUC measures the chilled water flow in gallons per minute and the water temperature both entering and leaving the building. The difference in temperature between the chilled water flowing in and the chilled water flowing out is what we call the delta T. The goal for our chilled water customers is to achieve a monthly weighted average delta T of 15 degrees Fahrenheit or higher. A delta T below 15 degrees will result in a rate increase on a fraction of your monthly consumption bill. On the other hand, a delta T above 15 degrees will result in a rate decrease on a fraction of your monthly cooling bill. You see, when the delta T drops too low, it causes pumps to work harder and consume more electricity, thus increasing costs. As a building owner, it's important to know the design rating of all of your air handlers and fan coils. For example, if coils are rated at 10 degrees delta T, the best performance you are likely to achieve is 10 degrees higher than the incoming water temperature. Our wholesale customers can request OUCooling to blend water up to the coil design temperature to help attain a higher delta T. However, for residential customers, chilled water metering and billing uses a different process that we'll explain in our third video. This diagram shows how we measure the water temperature and rate of flow entering and leaving the building. Notice the automated smart valve in the chilled water return line. This valve is linked to a temperature sensor located just before your building's internal pumps. An actuator opens and closes the valve to divert more or less of the warmer water from the return line to the colder supply line. This process regulates the incoming water temperature to match the building design temperature. In this example, the OUC chilled water enters the building at 38 degrees. However, the building design temperature is 45 degrees. With no blending, the water passes through the 10-degree rated coils and exits the building at 48 degrees. Consequently, the customer pays a slight penalty for a delta T of below 15 degrees. However, if the chilled water flowing in at 38 degrees is blended through the smart valve to the desired 45 degrees, the building's 10-degree coils raise the temperature to 55 degrees. Now the delta T reaches 17 degrees, so the customer receives a rate decrease on a fraction of the consumption of their monthly chilled water bill. It's important to note, the building owner or property manager can request a desired chilled water temperature to achieve maximum efficiency based on the ratings of their equipment. Your building's mechanical drawings contain a list of equipment, including the recommended inflowing chilled water temperature to achieve the proper delta T. Now that you understand the basics of how a chilled water system works, in our next video, we'll explore some of the problems that can lower your building's delta T and increase your costs. Thank you for watching. For more information, visit our webpage at ouc.com/OUCooling.